I'm Noah Ralston, and this is my final project for the Machine Learning Cert for product managers. The goal of this project is to build a model to predict the electrical energy output of a combined cycle power plant using readings from the sensors at the power plant. The criteria which will be used to grade this project is one, did I correctly identify the type of modeling, features, and possible algorithms to use? Two, did I compare at least two different models, whether that be using different algorithms, different features, or hyperparameters? And then did I use the correct validation set and cross-validation to optimize my model? Three, did I set a reasonable evaluation metric to determine the performance of my model and then use it on the test data? And four, did I correctly interpret and clearly communicate the performance of my model? The data used to build this model that was supplied by the power plant uh, consists of four variables and then a target variable, which we will be trying to predict. The variables are temperature, ambient pressure, relative humidity, exhaust vacuum, and then the target will be net hourly electrical energy output. I decided to split this data into a training set and a test set, which I split 75% and 25% respectively. Before building the model, I did an initial correlation analysis between the individual metrics and the target metric to see if there's any strong correlation. And you can see here that temperature and exhaust vacuum seem to have the strongest correlation out of the four. And this will also help with feature selection later. There's a few different algorithms I could choose from: simple linear regression, lasso, ridge, logistic, and softmax. The last two were taken out at right off the bat because those are more to predict different classes. I went with simple linear regression because it easily helps us understand the relationship between inputs and outputs, and also it's easily accessible in the Excel tool I will be using. Also, a couple output metrics that I could choose from. I decided to go with mean squared error or root mean squared error because it's a very popular regression error metric for models, and also it is heavily influenced by outliers, which, given our initial correlation analysis, didn't seem like there was that many large outliers in our data. To help select the features, I did a quick linear regression on the data set to see what coefficients for the different metrics would be the smallest to kind of see what the model would be using the least to determine the final energy output. You can see here that ambient pressure was by far the lowest coefficient, the closest to zero. So it seems that it is using ambient pressure the least to determine the final energy output of the power plant. So using that, I decided to do two different models, one where we use a linear regression with all the variables that were supplied at the beginning, and another where we did a linear regression without ambient pressure, as it seemed like it was being used the least to determine the final energy output. Running the regression on the first model, you can see we got a root mean square error of 4.505. And again, this is the one with all the initial variables as features. And then model two, we had a root mean square error of 4.51. And this is the one without ambient pressure. Looking at the performance of these two models, model one seemed to perform better as it had lower error. I included standard error here too, since it was supplied by the program that Excel was using. Um, and while small, Model 1 definitely performed better in both instances than Model 2. So I used the model, which you can see listed above, using the coefficients that were supplied and then put into a simple linear regression formula. And I used that to test on the test data. And you can see here that resulted in a root mean square error of 4.71. So in conclusion, the final model had a low root mean square error. However, it did increase when using the test data. I think going forward, I'd be looking for more variables to include as features. In a real life scenario, I'd ask the power plant if they could supply any more metrics that they capture from their sensors. I would also test different algorithms and use cross-validation folds so that I could actually test my models on more data as opposed to just a set validation data set. And then the final conclusion is that this was a great class. I really appreciated all the material that was supplied, and I think this was a really cool final project. Thanks for reviewing.